So usually we have what we call a ligand, which is immobilized or captured onto the sensor chip, and we flow over the second partner of the interaction in a constant flow of buffer, and this is what we call an analyte. When the analyte binds its ligand, it will create a difference in mass, which reflects the difference in the changes in refractive index on the thin layer of the sensor chip, and this is what the instrument is detecting. The change in mass and the changes in refractive index will create the binding event, which is a dose response curve, creating what we call an association curve from which you can derive your on rate. And at some point, the sample injection is stopped, but there is still a flow of buffer that creates the molecules to dissociate. And this is what we call a dissociation curve from which you can derive your off rate. Of course, there are two ways of calculating and deriving your affinity, either by plotting the response versus your concentration, and then you can get your affinity from the response from equilibrium. So this is the kinetic from equilibrium, but also more importantly, you can get your affinity from kinetics, which is a ratio between the off rate and the on rate. And this is what Creoptix has developed, both on the fluidics technology, but also on the sensor technology, and allowing you to do have high quality data for kinetic characterization.